Hi, I'm Michael Davies. I'm an analyst with Green Econometrics. I'm here today to talk about EV batteries and essentially the supply chain and the constraints associated with the supply chain in producing batteries, not just for electric vehicles, but also for the stability of the electric grid. With that, it's why is battery production important? And so the considerations include that the U.S. actually lacks the resources and the production capacity to meet the demand of electric vehicles. Electric vehicle manufacturers are proclaiming shifting to all electric vehicles in the not too distant future. And with that, there's significant constraints about being able to produce batteries to achieve those goals. Secondly, EVs and the batteries subsequently provide an energy transformation. So if the U.S. Does not have batteries, it leaves us vulnerable to economic decline and higher energy costs. And lastly, it's an imperative to really have energy storage to supplement the grid itself. And with that, it's the resiliency and the reliability of the grid, given the fact that renewable energies are going to be playing a larger role in supporting the grid. So with that, you need batteries to get us to where we need to go. And how I'll cover this is that I'll look at the battery resources. We'll look at some of the battery production technology and methods, the actual production of the batteries, and the takeaways. So the takeaways, as I try to reiterate, the battery production is limited by supply constraints and production capacity. We have some initiatives brought about by the Inflation Reduction Act that calls for incentives for battery production, and it's relegated towards countries that are part of the free trade agreement with the U.S. We are in a method now of looking at what is going to be important to get us on the right track to improve the production capacity. And it's going to call for coordination between the VC community, research and development, academia, private and public enterprise, to achieve a coordinated effort to ferret out what's viable, what's feasible in terms of meeting these production goals. So with that, let's just take a quick look at some of the resources that are involved. And I'll use some slides to help address that. And if we look at the market here, we see that battery metals for the production of lithium-ion batteries are going to include lithium, of course. The metals associated there, nickel, cobalt, manganese, and the associated price. We see that manganese is rather abundant in mining and has a low price. Cobalt, lithium are rather limited and therefore are associated with higher prices. And this is important because we need to know which countries, provide that framework. So if we're looking at, where to find these resources, these are the countries put together by the U.S. Geological Society: Australia, Russia, Indonesia, Brazil, Canada have, we'll say, relatively abundant resources in terms of at least nickel. Lithium is going to be relegated to a handful of countries. And therefore, it's important to establish relationships with countries that not only have a free trade agreement with the U.S., but also can provide the necessary inputs to achieve our production goals. So if we're looking at the production methodologies going into the battery itself, we find that it's important to achieve what are the relative metrics to determine the performance of a battery. And that's relegated towards the amount of power, duration of the power relative to the weight of the battery. So it's really the power to rate ratio, which gives us a measurable metric to understand battery performance. And so there's been a couple of approaches, namely reducing the amount of cobalt to reduce the battery weight. Tesla has shifted towards a dry electrode processing to reduce cost in the manufacturing, and these are helpful in better achieving the goals of higher performance, less weight. So if we take a step back and look at those countries that are actually producing batteries, it's important to understand, how they're utilizing the metals going into it. And so therefore, you look at China from this chart here, is the de facto leader in the actual refining of metals going into battery production. And therefore, that's kind of the example that needs to be shown as to why the U.S. Is lagging in this framework here. We see that Chile, Australia, and Canada are working in the refining of some of these metals, and it's important to really establish that relationship to better have a grip on the battery production. And this is not simple. Lithium-ion battery production is capital intensive, it's expensive and time consuming. In addition, there are dozens of distinct processes from electrolyte preparation, cell assembly, to electrochemistry activation, and not to mention quality control. So there is a lot of processes involved, and it takes time and a lot of capital to build out facilities that can achieve these goals. And what we're seeing is that if we look at actual battery production, China is the dominant supplier here. 76%, according to these estimates, is derived from China itself. The US is relegated to about 8% of the battery production, mainly from Tesla. When you look at Tesla itself, a good portion of their batteries are being supplied by China. So with that framework, it's going back to the imperative here, and that is developing a coordinated effort between academia, R&D, the VC community, public-private enterprise to expand our production capabilities in electric vehicles and battery production. Thanks.